right, so we're fortunate enough to have time to do a review day today. And what I'm going to do is just work through the final exam from last year. That's posted on the class website, but I usually don't write up solutions to final exam. So it's posted with a note that there are no solutions. The solutions will now be on videotape instead. Okay. Just want to remind you though, this exam is representative of what I consider to be a fair final exam. Knowing that it's out there, I will make sure that this year's exam is significantly different from last year's exam. So there are some incredibly important topics here, and probably some of them will show up on the final exam this year. However, if this exam is all you study, you are going to be grossly underprepared for the final exam. You want to make sure that you are reviewing your old exams and quizzes, all of that material. And then for the new material, which is the U substitution, just make sure that you've looked over your class notes. Hopefully you took notes as you watched the videos and completed the homework for that section. Okay, so this was question 1 on last year's final exam. We're taking the limit as x approaches 3 of root x minus root 3 over x squared minus 4x plus 3. So always the first thing I do is I see, can I just plug in 3? If I try to plug in 3 on the bottom, I get 9 minus 12 plus 3. Oh dear, no I can't, because the bottom is going to 0. So now I want to check if the top is also going to 0. This is an indeterminate form, and I need to do some work to evaluate this. If the top is not going to 0, that would mean I have a vertical asymptote. Do not assume you have a vertical asymptote if the bottom goes to 0 until you look at what the top is doing. If I try to plug in 3, top also goes to 0. So top and bottom both go to 0, so we have an indeterminate form here. Now I've got several options for what I could do. We've learned L'Hopital's rule at this point, so if I wanted to, I could apply L'Hopital's rule to take the limit. I think instead what I'm going to do, because this is just an algebraic function, I think instead I'm going to rationalize the top by multiplying by 1 in the form of root x plus root 3. Remember, that's the conjugate of this piece. Same two terms, but connected with the opposite sign. And if I do that, and I look at the limit as x goes to 3, now I've got to FOIL out the top, but because I have these opposite signs here, when I FOIL out, the outsides and insides are going to cancel. So my first terms will be x, outsides and insides cancel, and my last terms are just a minus 3. So I've got it's still going to 0, but it's a much simpler expression. Now on bottom, I don't want to multiply out, because here multiplying out gave me something simpler. Multiplying out on bottom would make things more complicated. So I'm going to just let that root x plus root 3 sort of hang out there. And what I want to do instead of multiplying out is I think I want to factor this. If I'm a polynomial and 3 makes it 0, I know that x minus 3 is a factor. And in this case, the other factor would be x minus 1. So I'm factoring the bottom, rationalizing the top. But now I can cancel that x minus 3. And so I've got the limit as x approaches 3 of 1 over x minus 1 times root x plus root 3. And now I can just plug in 3. So that's 1 over 3 minus 1 times root 3 plus root 3. That's 1 over 2 times this would be 2 root 3. So that would be 1 over 4 root 3. I'm fine if you leave it in that form. If you wanted to rationalize, you certainly could. That would make it root 3 over 12. I would accept either version of the answer for this problem. And certainly you could get there also by using L'Hopital's rule. You should get the same answer if you do it that way, of course.